Hello, today we're going to be looking at linear equations, also linear inequalities. We're going to be looking at these in one dimension, and then we're also going to be looking at them in two dimensions and talking about how they get graphed in each case. You're in, I assume, year 11 advanced math. So the stuff that we're going to look at today, you should have seen most of it before. The first half about linear equations, nothing here should be new to you. It should actually be revision of stuff that you saw in years 7, 8, and 9. But we're going to go over it quickly because it's really important that you do know it. So if you have any confusion, hopefully it will be cleared up by the end of today. Firstly, we want to answer the question, what is a linear equation? And so typically when we talk about linear equations, we're talking about this kind of line, y equals mx plus b. And this has four pronumerals. Can I put an s in there? Two of them are variables. They're x and y. They represent the horizontal and the vertical directions. And two of the pronumerals are parameters. So they're m and b. So the parameter m represents the gradient of the line, how steep it is. And the parameter b represents the y-intercept of the line, where it intersects with the y-axis. So if we have an equation like y equals x plus 1, the m is a 1, an invisible 1 in front of the x, and so that describes this steepness where for every 1 unit we go across, we go up by 1 unit as well. And then the y-intercept is 1, and so that means that we're intersecting the y-axis at 1 here. So this is a basic representation of a linear equation, and in fact, using these two parameters, m and b, the gradient and the y-intercept, we can uniquely describe any straight line on a Cartesian plane. Any one, doesn't matter which one, all of them. There's some nuance here. The hardest ones to describe are vertical lines, and the reason they're hard is the gradient is infinite and they have no y-intercept. Well, technically, they can have a y-intercept if they're on the y-axis, in which case they have infinite y-intercepts. But we're going to look at that type of equation today. That type of equation, we ignore the y, right? So we could take y equals mx plus b and take the y out of it. Now we have an equation that just is about x. And I quickly rearrange that, and so we have this solution that x is equal to, why does it keep doing that? X is equal to negative b over m. Okay, so on a two-dimensional plane, what we're doing is we're solving to find the value of x when y equals 0. In other words, what is the x-intercept? So coming back to this example here, if we set y to be 0 and we solve the equation, we get x equals negative 1. That's telling us what is the x-intercept of the line. Where does it cross the x-axis? Because we've sort of collapsed the y-axis, we're going to focus on plotting our solution on a one-dimensional line, which we call the x-axis. And so our solution x equals negative 1 is going to be shown with a dot right here. In fact, that dot is a little bit small and hard to see. Let me make it a little bigger. So that's how we would show the solution to this. We're going to build on that by looking at linear inequalities, which are exactly the same, except we replace the equal sign with one of these. We have a less than sign, a less than or equal to sign, which is a less than sign with a half an equals, a greater than sign, or greater than or equal to sign. Again, that's like a greater than sign, but it's got half a little equals there. Now, if you're confused about which one is less than and which one is greater than, I always remember by thinking of a crocodile, you know, the shape of a crocodile with its mouth open. The crocodile always eats the biggest thing. Okay, so in the case of the less than symbol, it's saying the thing on this side is less than the thing on this side. And you know that because the crocodile's trying to eat the thing on this side, the bigger side. Hopefully that makes sense for you. It doesn't change much. There's only one really important difference when we're solving inequalities compared to solving equations, and that has to do with when we multiply or divide by negative 1, multiply or divide by negative 1, we have to flip the inequality sign. So if we have 0 is less than x plus 1, we bring the x over, negative x is less than 1. Now we want to multiply everything by negative 1, so we have to flip that side. So now it's x is greater than negative 1. And I think it's worth thinking about that for a second. If you think, okay, negative x is less than 1, if you think about that, you should be able to make it make sense that therefore x must be greater than negative 1. So I'll leave that as a thought experiment for you. We're going to jump into some linear equations content now. As I said before, by the time you're in this course, you should be comfortable with solving linear equations. I'm going to work quickly through these examples. They're going to start really easy with some one-step equations, and then we're going to work up to things that are a little bit more complicated. So I recommend that you start by pausing the video, having a go. We've got 10 questions on the screen here. Maybe start with these 10, and then you can skip ahead and have a look at my solutions to check your answers. And then here are the next 10. So maybe once you check your answers for the first 10, have a go at these 10, and then skip ahead again and check your answers on these. I'm going to do these in type maths. Okay, so notice these are all numbered, but when I start solving them, those numbers are going to stop lining up to the question numbers. So just pay attention. See when I make a new line. Now the new line is 2 when question 2 has become 3. So I'm going to subtract 5 from both sides. We get x equals 7 for the first one. Next one, I'm going to divide both sides by 3. We get x equals 6. Next one, I'm going to add 7 over 2 to this side, which is going to give us 12 over 2, and 12 over 2 is 6. All right, next one, let's divide both sides by negative 4. That means 20 is going to become negative 5. Okay, next one, let's subtract 3 from both sides. To do it on a new line, subtract 3 from both sides, and then divide by 2. Excellent. Next one. I'm going to move the x's. I'm going to subtract 2x from both sides. I'm going to add 7 to both sides, and then I'm going to divide both sides by 3. Okay, this one, I'm going to subtract 4 from both sides, and then I'm going to multiply both sides by 3. This one here, we need to expand these brackets. No, actually, I'm not going to expand those brackets. First thing I'm going to do, and this one, I could expand the brackets, but that's going to actually add working. The first thing I'm going to do is I'm going to divide both sides by 2, and now I'm just going to add 5 to both sides. In this case, I'm going to add 2 to both sides. That's going to become 9. And then I'm going to multiply both sides by 4. So that's 3x now, and this is going to become 18. And then I'm going to divide both sides by 3. Awesome. I'm going to subtract 0.2x from both sides, and I'm going to add 2.1 to both sides, so that will become 3.6. Now we need to divide by 0.6. That's going to give us 6. Okay, in this question, I'm going to start by multiplying by 6. What that's going to do is it's going to get rid of the factor of 2 here and add in a factor of 3. It's going to get rid of that 3 there, and we're going to have a 2 here. So now we're going to expand our brackets. So this is going to become 14x plus 2. This is going to become 15x minus 9. I'm going to subtract 14x from both sides, and I'm going to add 9 to both sides. Okay, now I see the x down there. What do I want to do? I'm going to subtract 3/4 from both sides. Now, let's see. If I make this a denominator of 12, the numerator is 9. If I make this a denominator of 12, the numerator is 10, which means that this is 1/12. Now I'm going to multiply both sides by 12, and I'm going to multiply both sides by x. Perfect. Okay, so in this one here, I'm going to start by expanding the bracket, so this becomes 8x minus 12. Then I'm going to add 12 to both sides, and I'm going to subtract 5x from both sides. Now I'm going to divide by 3. And I'm going to leave my answer as an improper fraction, like that. Okay, in this one here, we're going to start by expanding these brackets, so this will become 3x plus 12. Here we're going to have a negative 2x plus 6. So collecting our like terms, that's very nice. We have one amount of x, and then we have plus 18. And if I subtract the 18 from both sides, we get that x is negative 8. Excellent. Okay, in this example, let's start by expanding our bracket. So this is going to be 10x minus 5. And then this is going to be minus 12 plus 3x. Now, collecting our like terms, we have 13x here, and I'm going to subtract 2x from both sides. And then here we have minus 17. And if I add that to both sides, this will become 24. And now I'm going to divide by 11. And again, I'll leave my answer as an improper fraction, like that. All right, in this example here, expanding the brackets to start with is going to give us 2x plus 3 right here. And then we're going to have minus 2x plus 1. Collecting our like terms, that's going to be a plus 4. Actually, these two x's cancel out. And now we get something that seems to be a lie. This question is not a valid question. This one cannot be answered. It is simply not true to say this like this. If this was in fact an inequality like that, then this would be true and it would be something we could work with. But even still, because we get 2x here and negative 2x here, those just cancel out and it's not really possible for us to find a specific value of x. Okay, moving on to the next one. This will be 2x minus 6. This will be 4x plus 20. Over here, we're going to have 6x minus 3. Again, this one can't be solved. The reason it can't be solved is we have 6x here, and if we subtract that, then that will subtract all 6x's here. Now we're left with this statement, and this statement just isn't true. It would be true if it said 14 is greater than 4, but it doesn't. So that one also is not available to us. But maybe we'll come back later. We'll see. All right, let's see if this one can be solved. I have a better feeling about this one. First thing I'm going to do is I'm going to multiply by 20, which is the lowest common multiple of 5 and 4. And so what that's going to do is it's going to put 4 here. We're going to have 5 here. And then this is going to become 14. Now, if we expand our brackets, that's 5x minus 15. This is 4x plus 8, which means we have 9x minus 7. If I add 7 to both sides, 9x is 21. And then if I divide both sides by 9, I get that x is 21 over 9. Now, I'm not done simply because 21 over 9 is not fully simplified. That's 7 over 3. And I can leave my answer as an improper fraction like that. Oh boy, we're getting close to the end of these questions. Let's see. So this will become negative 3x plus 15. This will become 4x plus 4. Over here, we have 2x plus 8. And here we have 3x minus 6. Collecting our like terms, 3x and 2x is 5x. Minus 6 plus 8 means we have plus 2. And over here, 4x minus 3x is just x, and 4 plus 15 is 19. Now we can subtract x from both sides, and we can subtract 2 from both sides, and then we can divide both sides by 4, and we get our answer there. Okay, lucky lost. What's the lowest common multiple of 3, 2, and 6? Well, that is 6, which is nice. On this side, we now have no fraction, nothing to worry about. Over here, we're going to have a 3 there, and over here, we're going to have a 2 there. Expanding our brackets, that's 3x plus 12. This is going to become 4x minus 2. Collecting our like terms, we have 7x plus 10 equals 5x plus 3. So we can make that 2x is negative 7, which means that x is negative 7 over 2. Oh, what a mission. So for those 20 questions, we've done 70 lines of working. Bear in mind there were 2 questions we didn't answer, but that means we're looking at about 3 lines of working for most questions. This one here had 4 lines of working, not counting the question itself. And some of our early ones had literally just 1 line of working, straight to the answer. Now you have seen the solutions for all of these, and just to be super clear, we can make a note that there were 2 questions which could not be answered. Those were 16 and 17. These I've generated all in ChatGPT. And in my outro for the last 2 weeks, I've warned you that ChatGPT is a great tool to use, but one of the risks is that it can make questions that look like real questions, but are not. So this is a great example to illustrate that you can't always trust the output you get from ChatGPT, but you can learn something in the process. Figuring out that some questions can be solved and some questions cannot be solved is actually a really valuable insight. Okay, carrying on. Now that we've had a look at solving linear equations, I want to have a look at solving linear inequalities. Now for these ones, I'm going to go through them one by one, so you can pause and play the video as we're going. That might be easier. And each one, we're also going to graph the solution. So this is going to take a little bit longer. But again, like the last ones, we're going to start with some really easy stuff, and then we're going to build pretty incrementally. We're going to build slowly. X is greater than or equal to 7. If we were to graph that on a number line, that's going to look like this. Because we have the greater than or equal to, we fill in the circle here. And greater than or equal to means that x could be anywhere in that circle or above. This will become x is greater than 6 on a number line. That means we have 6. Now this time I'm not going to fill in that circle. I'm going to leave it as an empty circle, which shows that we can't be 6. X cannot be equal to 6, but we show here that x can be anything greater than 6. In this case, we have that x is greater than or equal to 12 over 2, or in other words, x is greater than or equal to 6. This is going to look almost identical to the one we just did, except this time, when we put the circle at the 6, we fill it in because x can be equal to 6. A little arrow here to show that anything greater is also acceptable. Dividing by -4, we have to flip the sign, and we get that x is greater than -5. Means that we have -5 here. X is greater than -5. That means that x is in this direction here. Anything greater than -5 is a possible value of x. We have to keep this circle open. It can't be filled in. 2x is less than or equal to 8. In other words, x is less than or equal to 4. So we can take the 4 here because we can be equal to it. I fill in the circle, and then I simply illustrate that anything less than that is also acceptable. Subtract 2x from each side and add 7 to each side, and that gives us that x is greater than 15. Put a circle there, but I should make sure that it's not filled in because there is no equal sign, and x is greater than 15, so I'll put this arrow to show that anything in that direction is okay. Now you cannot give your answer like this on a test. You have to draw your number line appropriately. So maybe if I did it again, I would just put 0 here, and I would put 15 here, and I would put an open circle, and I would put my arrow like that. And that's fine. That's all you have to do. Your working out can be messy like this, but it's clear. There's 15, it's an open circle, and we're looking at x being greater. We subtract 4 from both sides, so we have x over 3 is less than or equal to 3, and then I'm going to multiply both sides by 3, which means that x is less than or equal to 9. So less than or equal to means I fill in the circle here, and I put a line with an arrow showing that our solutions are in that direction. 2x minus 10 is greater than 8, 2x is greater than 18, x is greater than 9. Okay, cool. So again, we're here. This time we don't fill in the circle, and this time our arrow, our line and our arrow go to the right to show that we're interested in values greater than 9. I'm going to multiply everything by 4 first. So I'm going to have 3x minus 8 is greater than or equal to 10, 3x is greater than or equal to 18, x is greater than or equal to 6. So here we fill in the circle, and we put our line, and anything bigger is what we're interested in. 0.6x, so that's subtracting the 2x from both sides, and then 3.6 is adding the 2.1 to both sides, and so then that gives us that x is less than 6. So again, empty circle, put a line going this way. Some of these answers feel repetitive. That's fine. They're all different questions. Sometimes questions will have the same answer. It's still good practice. Just because you get the same answer doesn't mean you're not getting new experience. Okay, I'm going to multiply everything by 6 here. So we're going to have 3 times 5x minus 3 is less than or equal to 2 times 7x plus 1, which means 15x minus 9 is less than or equal to 14x plus 2. Subtract 14x from both sides and add 9 to both sides. I get that x is less than 11. Now on the number line here, I'm going to, less than or equal to, I'm going to just add in the 11, maybe extend the line a bit, and then, oops. And then all we have to do is show that we're interested in values in this direction. X is less than or equal to 11. Let's see, if I multiply everything by 12, we're going to have 24 over x plus 9 is greater than 10. In other words, 24 over x is greater than 1. In other words, 24 is greater than x. Also, we could say x is less than 24. So this number line is completely useless because it doesn't go far enough. So I'll put in a new one. I'm going to say here is 0, here is 24. X is less than that, but cannot be that. So I put an open circle, and I say x is in this direction. Cool. 8x minus 12 is less than or equal to 5x plus 7. Subtract 5x from both sides. This is a 3x. Add 12 to both sides. That's a 19. Divide both sides by 3. 19 over 3. Now you need to know that 19 over 3 can be converted to 6 1/3. So we're looking at a value that is about here, right? Just above the 6. And this is a less than or equal to. So I'm going to put a circle that's filled in. And now I'm just going to add my line showing that anything less than that is also acceptable. 3x plus 12 minus 2x plus 6 is greater than 10. So x plus 18 is greater than 10. So x is greater than negative 8. So there's negative 8. We've got an open circle, and x is greater than that. So any value greater than negative 8, if we substitute it into any lines of working here, we will get a true statement. 10x minus 5 minus 12 plus 3x is greater than or equal to 2x plus 7. So 13x minus 17 is greater than 2x plus 7, which means 11x is greater than or equal to 24, which means x is greater than or equal to 24 over 11, which we can convert to 2 and 2/11ths, which means we're just above the 2 here. So we'll put in a solid circle there, and here x is greater than or equal to that. So we put our line with our arrow pointing in the positive direction like that. If you recall, this is a true statement, but we're not going to be able to solve this equation for x. So let me show you why that is. This is going to become 2x plus 3, and then we're going to have minus 2x plus 1 is less than or equal to 5. The two x's will simply cancel out, and so we get 4 is less than or equal to 5. That's not a false statement. It is true that 4 is less than or equal to 5. We could be even more specific. We could say that 4 is less than 5 because we know they're not equal. But because the x's cancel out here, there's nothing that we can do. This one's going to be similar. I remember from the linear questions we did. So we're going to have 2x plus 4x is 6x on the left-hand side. We're going to have 6x on the right-hand side, which means they're going to cancel out. So again, even though it may give us a true statement, we're not going to be able to get a value of x that we can graph. Multiplying by 20, this becomes 4x plus 8. This becomes 5x minus 15 is less than or equal to 14. Let's see, minus 15 plus 8 is negative 7. If we add that, we get 21. 4x and 5x is 9x. In other words, x is less than or equal to 21 over 9, which is 7 over 3, which is 2 1/3. X is less than or equal to 2 1/3, which means if 2 1/3 is there, we need to put a filled in circle, and we need to put an arrow showing that any solution less than that is also acceptable. 3x minus 6 plus 2x plus 8 is greater than 4x plus 4 minus 3x plus 15. 5x plus 2 is greater than x plus 19. 4x is greater than 17. X is greater than 17 on 4, which is 4 1/4. So 4 1/4 is about there. We put an open circle, and we show that x is anything greater than that value. Last one, let's multiply everything by 6. This will become 4x minus 2 plus 3x plus 12 is greater than or equal to 5x plus 3. This becomes 7x plus 10 is greater than or equal to 5x plus 3, which means 2x is greater than or equal to negative 7, which means x is greater than or equal to negative 7 over 2, which is equal to negative 3.5. So that would be about there. Now we're at greater than or equal to, so we fill it in, and we show that greater than is the direction we care about. Cool. Okay, now we get to some fun stuff. We're going to look at what we call compound linear inequalities. Given that we found some of the linear equalities questions we had were unanswerable, I actually think there's a good chance we're going to find something similar here. But at a glance, they look okay. So what we're going to do is we're going to look at how we solve these, and we're also going to look at how we graph our solutions. What we're doing is essentially exactly the same. There are no new rules. But instead of saying you have to do the same thing on both sides of the equal sign, we don't have an equal sign, we have inequality signs, and you have to do the same thing to every side of every sign, right? So if I'm going to subtract 3 to get x on its own, I have to subtract 3 here as well and also here. So we're going to get that negative 1 is less than or equal to x, which is less than 4. And if I want to graph that, I'll do it like this. I'll say, let's put 0 there. We'll say that's negative 1. We'll say 4 is over here. And so what we know is that x is less than 4 and greater than or equal to negative 1, which means that x exists in this interval here. I'm going to start by adding 1, so that becomes negative 3 is less than 2x is less than or equal to 11. And I'm going to divide by 2, so negative 1.5 is less than x is less than or equal to 5.5. Chuck 0 there, let's say that's minus 1.5, and then over here this can be 5.5. This one is strictly greater than, this one is less than or equal to, and then we just show that our solutions are somewhere in the space here. Okay, so now this is a little bit different because we have these two inequations that are not in one big statement, they're separate statements. So we're going to solve each of them for x, and then we're going to put them together. So in this case, let's add 3 to both sides. So we've got half of x is greater than or equal to 1. In other words, x is greater than or equal to 2. And then over here, we have x is less than 5. So if we take a number line, say 0, 2 can be there, 5 can be there. And so what we know is that x is greater than or equal to 2, that's this direction, and x is less than 5. So that's what our solution is going to look like. Okay, let's multiply everything by 4. So 3x plus 1 is greater than or equal to negative 20 and less than 8. Subtracting 1, that's now negative 21, and that's now 7. And then dividing by 3, negative 7 is less than or equal to x. Is less than or equal to 7 divided by 3 is 2 1/3. So on a number line, I'm going to put 0 here. That can be 2 1/3. That can be negative 7. So x is greater than or equal to this one, and x is strictly less than this one. And then I just need to draw a line between them showing which values we're interested in. Lucky lost. So 2x is greater than 8, x is greater than 4, and then here x is less than or equal to negative 3. So this is a really interesting one because here we have something kind of different. If I mark in 0, 4, negative 3, what we actually have here is that x is above the 4 or x is equal to or less than the negative 3. So in fact, instead of having one part of the number line where our answers must exist, now our answers must exist in one of two parts of the number line. Or to flip it around, we could say there's one part of the number line where our answers cannot exist. Now that we've looked at inequalities in one dimension, I want to bring back the y. We're going to go into two dimensions. So what I'm going to do is I'm going to work through these 5 examples here, and I just want to illustrate to you how we rearrange them. We're going to put them all into the straight line formula that you're used to of y equals mx plus b. And once we have that, obviously the equal sign will be an inequality. Once we have that, we're then going to think, okay, what does this line look like? And are we above it? And are we below it? And do we have the possibility of being on the line or not? So here are the first 5 examples that you can attempt if you want to work ahead. So in this first one, this becomes y is less than or equal to negative 2x plus 8. If we want to graph that, let's say that's 8 there, and if our gradient is negative 2, that means we're going to cross here at 4. Our graph will look something like that. Now, because this is less than or equal to, that means we use a solid line. If it was strictly less than, and we're going to see this in upcoming examples, we would use a dotted line. Because it is less than, however, it's less than or equal to, because it is less than, we're interested in that line and everywhere under that line. So when we show our answer to this type of question, we have the line as a solid line, and then we color in or shade in everywhere on the graph that's below that line. In this case, we're going to say x minus 5 is greater than 3y. In other words, y is less than 1/3 x minus 5 on 3. So if we want to graph that, we notice this time we do not have the or equal to. It is y is strictly less than. So because it's less than, we know we're going to color in below the line, but we need to think for a second about where the line's going to be. So a gradient of 1/3 is pretty shallow, and we're going to cross at minus 5/3. So our answer is going to be like this line, except it needs to be a dotted line, like this. But we're also going to shade in everywhere below that line. So any xy coordinate under this line will satisfy that equation. In this case, we have 2y is greater than or equal to negative 4x plus 12, which means y is greater than or equal to negative 2x plus 6. Because we have the greater or equal to, that makes our lives a little bit easier because it means that we can draw the solid line instead of having to do a dotted line. Minus 2x is pretty steep, so if this is 6 here and that is 3 there, our line is going to go through those 2 points like this. And because y is greater than or equal to, this time, instead of coloring below the line, we're going to color in above the line. Now, because this line is so steep, it makes it a little bit less clear which direction is up and which direction is down. But if you just pick any point on the line, and then you say this is up and this is down, it should be really obvious to you which side of the line you need to shade. In this example, we have y is less than negative x plus 7. Now, because it's strictly less than and there's no equal to, it means we're going to have to do a dotted line. Negative x is kind of like a 45-degree angle, so something like this, and it's going to cross at 7 there, which means it'll cross at 7 there as well. And because y is less than it, we're going to shade below the line, like that. In this case, 3x minus 4 is greater than or equal to y. Cool, that was easy. So drawing our Cartesian graph, 3x is quite steep. We're going to pass through minus 4, but we're going to be going up fairly steeply. I'm very grateful that it's an or equal to in this case. Now, what's the x-intercept going to be? If y was 0, if we had 3x minus 4 equals 0, just for a second, we'll say 3x equals 4, x equals 4 on 3. So 3 and 1/3 is this coordinate here. And y is less than or equal to this, which means that we're going to be shading in under the line, just like that. Cool, that's all there is to it. But wait, there's more. Just like how we had these examples where we had compound inequalities when we were working in one dimension, we can also have compound inequalities when we're working in two dimensions. So let's have a look at these. For the first one, we're going to have y is less than or equal to negative 2x plus 8. And for the second one, let's see, this is going to take more work. X minus 5 is greater than 3y. In other words, y is less than 1/3 x minus 5 on 3. If we're graphing this, if this is 8 here, and then that means 5 on 3, which is 2 1/3, is going to be, so if that's 4, that's 2, 2 1/3 is going to be there. That can be 4 there. And if that's 4, then that means that's 5. Oh, so negative 2 1/3 is going to be like down here. Firstly, from the left-hand side here, there's our first line. And y is going to be less than or equal to negative 2x plus 8, so we're going to be below it. And then for our second line, it's going to be a dotted line, frustratingly. And this one is going to go through these points like this. We've actually already graphed this guy. And in this case, again, y is less than it. So we need to be in a space on this plane that is less than both of them. And so that's going to be in this space here. So we can't be on the dotted line. We could be on the solid line, but anywhere that is underneath both of them is going to be acceptable. So this is how we graph our solution to this question. Okay, that's good. So we've got our first line. If we call it y1, y2, and y3, we have y1, y2, and y3. So we have to be above y1, because it says y1 is we're greater than that. y2, we have to be less than the line. So that means we're in this space between these two here. We're above this line, but below this line. And then we have to be less than the other line. So in this case, we're looking at this space here, like that. Okay, y is less than or equal to negative 2x plus 8. I'm seeing some real recurrent equations popping up. Y is less than 1 on 3x minus 5 on 3. And y is greater than or equal to negative 2x plus 6. Awesome. Through the 8 and the 4, and it's a solid line. Our second line is going to go through negative 5/3. That's negative 2 1/3. And then it'll cross at 5, which is going to be there. And this one is a dotted line. And then the last one, negative 2x plus 6. Oh, interesting. This is parallel to the first line because it also has that same gradient of negative 2. Okay, so the first one, we've got to be below it. Good. We have to be, yeah, no, that's fine, below it. Second one, we have to be below it. So we're in this bottom zone. And then the third one, we have to be above it. So that means to be below the first two and above the third, we've got to be in this space here. In summary, today we have covered solving linear equations, including with fractions, decimals, and brackets. You should be able to do that. You should have been able to do that before today. Then we built on that, solving linear inequalities. The one catch, if you recall, is if we multiply or divide by a negative number, we have to flip the sign. Then we had graphing linear inequalities on a Cartesian plane, and we also looked at graphing solutions to multiple linear equalities on a Cartesian plane. Please complete the worksheet for this week's lesson as a practice test. If you would like more practice questions, I recommend you start by reattempting any you got wrong and make sure you can get them right without looking at any solution. It's also worth trying to make up your own questions. And as I mentioned as well today, ChatGPT is worth asking for questions. That's where I get a lot of the questions I include in these lessons. But you can't trust it to give you questions that will work. Sometimes they'll look sensible, but they won't actually give you a sensible answer. And similarly, if you ask ChatGPT to give you the answers to the questions it's given you, you can't trust it to give you the correct answers to those questions. I hope you learned something, or at least got better at something today, and next lesson we'll be looking at more equation work. We're going to look at equations that involve absolute values. We're also going to look at simultaneous equations. And as you can probably tell, we're moving on from year 8 and 9 content revision, and now we're getting up to year 10 content revision, or 9 and 10 content revision. And soon we'll be getting into some new stuff, but it's really important just before we do that we make sure you are completely across all of these foundational skills. Have a great week, and I'll see you in the next one.